Today's objective is to be able to factor the greatest common factor of expressions by finding what terms they have in common. In our first lesson, the greatest common factor of the expressions that we worked with only had constants. In our second lesson, the greatest common factor of our expressions only had variables. Today, we're going to be putting those things together, and we are going to look at expressions whose greatest common factors will have both a constant and a variable. So let's look at example 1. We have 21x squared plus 14x. We want to factor this expression, which means we need to rewrite this expression as the product of two things, where one of those things is the greatest common factor. In other words, we want to figure out what two things, when you multiply them, will give you 21x squared plus 14x back. And again, one of those two things has to be the greatest common factor. Just like in our previous lessons, we're going to factor each part of our expression separately, and then we will look at what the different parts have in common. So we have 21x squared plus 14x. So we're going to factor these two parts out separately. So first, we're going to look at 21x squared. We're going to factor out the coefficients. So for 21, we want to figure out what numbers, when we multiply them, give us a value of 21. And I know I can always start with 1 times 21. Those are two factors of that number, because 1 times 21 gives me 21. If I try 2, when I divide 21 by 2, 2 does not go into 21, so 2 is not a factor. However, if I try 3 times 7 gives me 21, which means 3 and 7 are both factors of 21. And there are actually no other factors for this number. So now we're going to look at our variables, and for every part of our expression, we're going to take the variables and we're just simply going to expand them out first. So for x squared, if I expand out x squared, that means that I'm using x 2 times in multiplication, so that's x times x. Now let's look at our other part of our expression, which is positive 14x. First, we're going to figure out what are the factors of 14, and I know 1 times 14 gives me 14. If I do 14 divided by 2, I know 2 times 7 gives me 14. And these are actually the only factors of 14. So 1, 14, 2, and 7. And I have x to the first here, so I only have one x here that I need to expand. So now that I've expanded both sides of my expression, I've expanded the 21x squared, and I've factored or expanded out the 14x to the first, I need to figure out what are the things that they have in common. So first I'm going to begin with the coefficients, and I want to figure out from our coefficients what is the greatest common factor, or the GCF, just for our coefficients. And if we look through our list, we see that the biggest number in the list of factors that they both have in common here, for 21 and 14, is the number 7. So the first part of my GCF is going to be the number 7. However, I'm not done, because I see that both of these terms have variables, and I need to figure out what variable, if any, do they have in common. In this case, I see that they both have x's. So I need to figure out how many x's do they both have in common, and it has to be the same number for both terms. And when I say this, the same number, I mean the same number of x's. So I see that 21x squared has 2 x's, and I see that 14x has 1 x. So the biggest number of x's that I can circle on both of them would just be 1. In other words, I can circle 1x in both of these expressions. So I'm going to take that x and I'm going to keep it as part of my GCF. So just to recap, I factor out the 21 and the 14. I factor out the x squared and the x. 7 is the greatest common factor of both my coefficients. And I can circle 1x from both of these terms. So that x that they both have in common, I can bring it as part of my GCF. Notice that I can't circle this other x here, because this term over here does not have an extra x for me to circle as well. Whatever we circle as part of our GCF has to be in common for both of our terms. So now that I know my GCF, I need to figure out what's the other factor of my expression that I'm working with. Remember, if I'm factoring 21x squared plus 14x, that means that I'm finding two things that I'm multiplying by in order to get me back to that expression. Well, I found one, which was my GCF, and it's equal to 7x. And just like in our previous lesson, we're going to take our original expression and we're going to divide that by our GCF so that we can figure out what that other factor is. So now make sure that you have ones in your exponents so that you don't forget that you're still working with those x's as well. And as we learned from division, we're going to take this bigger fraction and we're going to break it up into a smaller one. So we have 21x squared over 7x to the first, and then we have positive 14x to the first over 7x to the first as well. And now we can go ahead and divide out. So 21 divided by 7, that's going to give me 3. And then x to the second divided by x to the first, just as a little review from division, we keep the same variable, we keep our x, and then we subtract the top exponent minus the bottom. So 2 minus 1 is just x to the first power. Then we do the same thing for our second part of our expression. Positive 14 divided by 7 is going to give me a positive 2. And when I do x to the first times x to the first, well, that's the same thing divided by the same thing, so that's going to turn into a 1, which we don't have to put there because 2 times 1 is just simply 2. So my GCF was 7x, and the other factor that we found by dividing by our GCF was this 3x to the first plus 2. So now remember that we must take those two things and use them to rewrite our expression as the product of these two things. So here my answer will be my GCF, which is 7x, times the other factor that I found by dividing by it, which is 3x to the first plus 2 in this case. Now remember that if you're not too sure whether you did the right work or not, you can always check your answer to see if what you got is correct. So let's see how we can check this answer. We have 7x to the first times 3x to the first plus 2. And again, the way that we can check is by just multiplying the two things and see if it's going to take us back to what we originally wanted in our problem that was given to us. So I can distribute, I can have 7x to the first times 3x to the first, and then I have 7x to the first times positive 2. And let's see if that gives us the same thing. 7 times 3 gives me 21. And x to the first times x to the first, when I'm multiplying, you got to be very careful and determine the operation you're working with. When I'm multiplying, I keep my expression. Anytime you're multiplying something, it's getting bigger. So I'm going to add the exponents to give me 2. And then when I do this side, 7 times positive 2 gives me positive 14. And I have this x to the first here, which is not being multiplied by anything else. And we can see that it's exactly the same exact thing that we had in our original expression, which means that we've done the work correctly. So let's look at another example, which is just a little longer than the one that we did before. So we have factor 8x to the fifth minus 24x to the third plus 16x squared by finding the greatest common factor. First, I want to make a note that this says for us to use the greatest common factor. You might see a multiple choice question that will factor this out, but will not use the greatest common factor. So you want to make sure that when you're selecting an answer, you're selecting an answer that has the greatest common factor as one of the two things that you're multiplying. So we have 8x to the fifth minus 24x to the third plus 16x squared. So we're going to do the same thing and factor these pieces out separately. We have 8x to the fifth, negative 24x to the third, and positive 16x to the second. We want to make sure to begin with our coefficients. I know the factors of 8 are 1 and 8, 2 and 4, and there's nothing else that we can list here. Now for x to the fifth, what I'm going to do is take that x to the fifth and expand it out. So I'm going to take that, and x to the fifth is telling me that I'm using x 5 times in multiplications. That's 1, 2, 3, 4, 5. Then I do the same thing with 24. And again, when we're looking at negative terms, you can ignore the negative sign when we're looking for the factors of the coefficient. We include that negative sign once we start dividing out our terms. But right now, we don't have to worry about it. So I have 1 times 24. I have 2 times 12. I know 3 times 8 gives me 24. And 4 times 6 gives me 24 as well. And those are all the factors of 24. For x to the third, that's telling me to use x 3 times in multiplication. So that's 1, 2, 3. And then for 16, the factors of 16, I have 1 times 16, 2 times 8, and 4 times 4. For x squared, that's telling me to use x 2 times in multiplication, so that's x times x. So now that I factor out my coefficients and I've expanded out my variables, I have to figure out what do those 3 things have in common. So now the only difference is that instead of looking at 2 terms, we're looking at 3. So whatever we circle in one of these terms has to be able to be circled in all the other terms that I have here as well. So we're going to start by looking at our coefficients. So if I look through the list of coefficients, the greatest number that they all have in common, that 8, 24, and 16 have in common, is the number 8. I see that they also have a 2 in common. I see that they also have a 4 in common, but the biggest one that they have in common is the number 8. Now I have to do the same thing with my variables. I have to figure out how many x's can I circle in all 3 of these. To start, I know that I can circle 1x in all of them, but I see that I can also circle another one. I have another one here, another one here, and another one here as well. So let's list all the parts of my greatest common factor, or my GCF here. First, I know that I have an 8 in common, I have an x in common, and I have another x in common as well. But if I simplify this, this is just 8x to the second power, because I'm using x 2 times here in this term. So my greatest common factor here is 8x to the second power. So again, now we have to take our expression and we have to divide by our GCF to figure out what the other factor is. So I have 8x to the 5th minus 24x to the 3rd plus 16x to the 2nd divided by 8x to the 2nd power. We're going to break that up into smaller fractions. So I have 8x to the 5th over 8x to the 2nd. I have a negative 24x to the 3rd. Here is very important for you to make sure you're keeping track of those negatives. We don't want to forget them here. Over 8x to the 2nd. And then I have a positive 16x to the 2nd over 8x to the 2nd again. So now let's divide out these numbers. I have 8 divided by 8, which gives me a positive 1. And then I have x to the 5th divided by x to the 2nd. Again, I keep my variable and I subtract the top exponent minus the bottom, so that's x to the 3rd power. Then here I have negative 24 divided by 8, which gives me negative 3. And x to the 2nd divided by x to the 3rd divided by x to the 2nd, I keep the x, and 3 minus 2 gives me 1. Then last but not least, I have positive 16 divided by 8, which gives me a positive 2. But this x squared divided by x squared is a 1, which we could put here times 1, but 2 times 1 is just 2. So remember that this is not our final answer. Our answer is going to be the product of our GCF, which is 8x squared, and the other factor that we found, which is 1x to the 3rd minus 3x to the 1st plus 2. If you want to check, you can go ahead and multiply these two things and see that it will give you the same expression that we began with in the problem up here.